Welcome everybody to the first ACM workshop of the semester of spring 2022. Our workshop our workshop is going to be given by Alexander Betancourt, who is a wise and noble individual, who is a Python person, Python wizard, and is very fond of memes, as you might know if you've seen him on the memes channel here on the ACM Discord. So he's currently taking my CSci 45 class, and he's also a tutor in the tutorial center at Reedley for math and Math Center. But do you help with both math and computer science, or just math?
Yeah, we actually do both computer science and math at the Math Center.
Math Center. So he's a tutor at the Math Center.
We also do engineering too.
Gotcha. And he is TAing for CSci 58. Is that right?
Yeah, CCI 58 with Sultana,
which is a Python class. So he is. Geez, Kearney, get it right. So he is our resident Python person, at least for the day. Next week we're going to be having Aaron Hare, who is talking on the workshop channel right now as well. He's going to be doing a follow-up to this workshop. So if you like Python, it's a good language to start programming with. I'm going to start muting people because I think some people don't know that they're not. This is an open mic channel, so you can always just jump in. If any of you have any questions for Betancourt, just interrupt him, start yelling at him, ask a question.
Yeah, go ahead.
And he'll answer you. And I think that was Cabrera. Yeah, Cabrera sounded like he was doing some woodworking. So this is a open mic channel, so just make sure you mute yourself if you're not talking. And that's it. So this will run until 5:04, so you have a full hour. I'm not going to take any of your time beyond this, and I'm going to turn my face off and take it away. Betancourt.
Okay, just checking the terminals up. Okay, so this is Python. This probably should be your first time seeing it. Some of you, this is probably the millionth time seeing Python. And for those who this is the millionth time seeing Python, I got a little activity set up for you. It's basically these four mini assignments I made for you guys. Not a big deal if you do them or not. We're going to go over the solutions later on, because the whole point of the demo is to show off CCI 1, basic stuff about programming. So you can get started on that if you will. Go crazy. And I kind of formed it like Kearney's programming assignments, so yeah. So this is Python. This is your IDE. And let me show you how to make a Python file in Visual Studio Code. So if I want to delete this file, I can go right here, make a new file, name.py. I know Kearney recommended that some of the CCI 1 students use Replit, which is like the same thing. They already make the file for you. You can just do a print like this. Which, by the way, if you want to print to the screen, use print. Very simple. It's not like C++ where you do like cout, string. So hello world. It's very simple. And that's the thing about Python and how it's designed. It's meant to be really simple. But since your C++ hello world, this is your Python hello world. Press run. It'll run it for you. There you go. That's how you do it on your online IDE, but since I already have it installed locally, I'm going to be using Visual Studio Code for this, which I do use for C++ as well. So, yeah, you can use Vim too if you really want to. Hazelton could probably get into that. So, if you want to print to the screen, the basic first thing you do in Python, you usually print to the screen. Like how it works for every language is like, how do I print to the screen? Like I know what we did 45, the first thing I asked was, how do you print to the screen in assembly language? But usually in every language, just the first thing you do is print to screen. So in Python, that'd be the simple print statement. When you do your print, your string, and hello, put it on there. And since I'm using this terminal, I use the command prompt to compile this. By the way, if you really want to, you can use the shell too. You have options. It's Python. Okay. So if you really want to use a shell, you just type Python or Py. For example, if you have a you have different installations of Python. You can use Py or Python 3 if you're on. I think if you download it from the, I think because I download it from the Windows Store, I can use Python. But if you download it from Python directly, you're gonna have to use Py. Or if you're on Linux, you use Python 3. But yeah, you can use the shell for this. And we can go here, do your little shell. You want to do 1 plus 1? 9 plus 10? It's not 21, it's 19. So, we're good day right there. If you want to do print, you just go to print like this. Does it. And, pretty simple stuff there. And plus, if you want to, you can declare variables too. Say A is equal to my name, right? My shell, right? If I really wanted to print out the screen, I can do this. Yeah, this is the shell. Nobody really uses the shell. It's just something there for beginner Python users to get used to. But it's there. I know they go over it in the first week of CCI 58, because the whole point is to learn as much about Python before you take your certification exam to become certified in Python. So it's one thing they do go over. That's something I don't go over. Because I took it with Rio Waller at FCC under CIT 95. She did a really good job. It's just that it's more business oriented, so it's more about making business applications. It's not really about computer sciencey stuff. So if I wanted to run this script right here, I would just cd into it, because if you're used to the Vim server that Kearney has, you can just look for a directory like this and just say. But keep in mind, you can't do ls because this is Windows, because Windows is dumb. I can just cd into the demo by tab completing. I can do this, so I can do Python main.py, compiles, and there it is. Not really compiles, it's more of like interprets and then prints it out screen. So you know how to input the screen now, right? It's pretty simple, right? Just one line, print. What if you want to do input? Oh, if you want to run a Python file from the terminal, you can also use the terminal right here in Visual Studio Code. Same thing. You can do cd. Let's go to demo. You can also do ls too. For some reason, the terminal Visual Studio Code will let you do ls because it's PowerShell instead of command prompt. Unless you do cls if you want to. So you can just do Python main.py, so the name of the file, which I usually call it main.py. And I can just run it like that from the terminal. And plus you can see your problems down here, which is an input issue we'll get over later. But yeah. So you know how to print the screen now. Let's go about input. So so basically Python's a very simple language. Like I can read this out to people like, oh, just print hello world. They're probably gonna guess what output is, or input is. It's input. Wish it was more easier to say than that. Yeah, it's just input. So remember how Kearney's read library works? If anybody is in the server right now, you can just declare a variable, right? And say a is equal to a blank string, and I can put a is equal to input. But pass someone to Kearney's read library, you can put a string in here. So I can say enter your age. Key. Right? It's kind of similar to Kearney's read library. We can have a string, and it outputs the string before you do your input. So go here. I can do main.py again. By the way, it auto-saves, but if you can't auto-save, just do Control-S. It saves for you. Go here and you do main.py. I run it, like terminal quickly. Let me run it. Why is it not letting me run terminal? There. Main.py. I go to my age right here, 20. It's kind of similar to Kearney's read library, where you can just have it do a string before you do an input. It's basically Kearney's read. But since some of you never seen this stuff before, technically speaking, it's the first time you're messing around with input, which opens up a lot of other opportunities. For example, I can print this output to the screen, but I'm just going to put this in here. It's like printing read. But yeah, as soon as you can get input, it opens up a lot of opportunities. You can also print the variable to the screen. So using A, you can just run the script again by doing Python main.py. I enter my age. It says straight back to me. It's kind of basic stuff, but not kind of get into the flow of doing Python a little bit differently. And you're probably gonna ask yourself, well, if statements, right? Because most computers languages have if statements or some sort of logic to them. Well, we do it a little bit differently in Python. You know, you're probably used to C++, like, oh, if braces this, semicolons, you know, everything ends with semicolon. Python's much more different. We don't have any of this. We really want to. You can do something like this, where you have your statement saying A is not equal to this, then run the code. But in Python, you do an indentation. Yeah, we don't have those fancy curly braces. We just do a flat colon indentation. So we just do tab. Pretty different, huh? Pretty wild there, huh? If it's not 20, right? Yeah, it does. Whitespace does define scope. That's the other way of putting it, but I didn't want to start using big words right away, because, you know, it's easy to get one. But yeah, whitespace does define scope. So this is basically saying that this if statement, it's kind of similar to what we do with semicolons, curly braces in C++, where we just say this is inside the if statement, but really it's about whitespace. So we put whitespace between here. We can say you're sus if you're not 20. Otherwise, else. Okay, let's do else right here. And we do print. That. Basically, how it works is that if you're not 20, prints this. If you are 20, print this. Basically an if-else block in Python, because all we're doing is just doing the semicolon tab, then the statement. So if I run this in the terminal, yeah, because it's not. Oh, I know why. So, think about this is another problem about Python. Your variables are dynamic. They don't have a set type. So, you might get these errors where it's like, I'm inputting an integer into a string, which returns a string. So, input returns a string. And that's probably the reason why this code's not running, because I'm just comparing it to a number. Comparing a string to a number, of course, it's always going to go to this right here. It's no problem with Python. But if you want to specify a type it's going to return, you can always do an int keyword. It just converts anything to an integer. Even shows some nifty documentation if you're on Visual Studio. So that's another way of doing that. So we run this again. There you go. There's another reason why it was false, because of types. Python doesn't have types, so sure it's simple on paper, but I kind of miss the static type system that C++ has. But yeah, it's generally easier for beginners because they can't like say, oh, I'm trying to put a boolean inside a string or whatever. They can't like do that kind of mistakes. At the same time, it kind of confuses people who've been doing other languages for a while, because you can have like this kind of error where it's like, oh wait, it's not an integer, it's a string, so it's going to go straight to this block of code right here, which is going to be a problem if later on. Plus, plus some of you guys are working on section 1 right here. You can chain these functions pretty easily. So if you really wanted to, you can do this. You can do a print function and input function. Let's do like this. So remember how if you're going to put other workshop, right? The Minecraft workshop, we had this big thing of function chaining, right? We're gonna end up chaining a lot of functions to do make an item in Minecraft. This is kind of similar to that, where you can have function chaining in Python. You have something like this. Prints out the screen. It is the same thing as this. So if I really want to, this is something really nifty about Python. I can do this. Right here. I can do this. I don't have to declare it in a variable. Get rid of the if statement. And do that. So though basically if I run the script again, it'll print out the result when I put an input. Pretty rad, isn't it? So if I really want to as well, I can do something like this. The evaluation keyword, which evaluates strings inside the input. So I can do something like this. Do something similar to what our shell does in Python. So, I don't know. Something might be important in the future. Because if you put evaluate, it actually evaluates it like it's an actual equation. It says right here, in documentation. Evaluate the given source, the contents, the globes, locals. And literally, if you put something that's a string like 1 plus 1, you can evaluate it. So that's basically inputs and outputs. The reason why I'm going a little bit too slow on this, because we have CSI 1 students in here. And I don't want to, because it's their first time seeing this. Some of them, this is probably like kids play them. Some of them, this is the first time seeing programming being done. So I really want to. Let's go over this stuff as well. You can also go over lists too. But I think we should just go over a little bit more about printing screen. Should I go over printing and screen or just go over lists? So I think lists are the next part over this. Or we can go over loops. So loops are very similar though. In Python, loops are very similar to how we do it in C++. Except in Python, we're more focused about indentation. So if you want to do a while loop, I prefer while loops in Python. It'll just be the same thing but with an indentation. So if I want to do that calculator I was talking about, we're supposed to do in the first little activity I gave you guys. No, it treats it like it's an actual equation sometimes. So if I did this, I did a while right here, while true, t true. I pass in print, eval, input string. I can basically make this into an infinite loop if I really want to. So if I go here, our terminal, we'll just give you a terminal right here. CD for the demo. Just do Python main.py. And we do our little evaluation again. So we do 20 plus 20, 40. We do our evaluation, let's say, I don't know, 300 modulus by 2, 0 for some reason because it divides evenly. Or 1, 2, 31 modulus by 2. Just the remainder of 1. So yeah, it evaluates like its equation. But later on, we can actually evaluate strings and turn them into actual normal strings. So do string literals and turn normal strings. That's the thing we're going to do in the next one. So that's how loops work. It's very similar to how loops work in C++. We have while loops, for loops, and for each loops. So, well, it's a very similar language. But I use while loops when I'm working with Python because while loops are just easier to write than for loop for me when it comes to Python. Because for loop you don't have the same, like, for example, you don't have the usual, like, for int I is equal to 0, I is less than 0, and 10, I plus plus. You don't have that. So it's very different than what you normally do. That's the reason why I use the while loop. It's just basically the same thing. It's easy translation over. And another advantage of Python is that you can import libraries a lot easier. So if anyone had this experience in C++ or other languages, getting external libraries is very difficult. Like, for example, installing Kearney's read library into a Windows machine, and you already have C++ set up, it's pretty difficult. But in Python, it makes it a lot easier. So if I want to, I can go to the command prompt, right? I can just do pip, do version. So pip is a way of installing external libraries. Yeah, like Pip-Boy. But I don't know what they named pip after. But yeah, it's just a way of installing external libraries. So if we notice back, let's go to one of the assignments. Let's do it right now. The cow assignment where you import cowsay. We're gonna have to import it from a different library. So we're gonna do, let's go to our terminal, and we're gonna do pip m install cowsay. I'm pretty sure I did that wrong. But yeah, you'd use, like right here. I'll show it right here. Go to our documentation right here. I can get the actual pip statement, because I don't know why pip's not working right now. Depending on what version of Pi, it's a different pip. So if on my laptop, you would do pip-m install, but we can just do pip install on this computer, which it collects the packages from pip and installs it on our computer. So now when we refresh our IDE, we could right here to command palette, refresh reload window. It'll actually recognize the package. So very clear. We import a package cowsay, and it even says right here it's not accessed, but it does recognize it as a module. I'm telling you. And plus I have request here for HTTP requests. So let's say you wanted to solve this real quickly. You want to bring back the cow everyone loves from our server, which Curdy got rid of, slaughtered, gone, relatable. You can get this under 2 lines and 2 imports. So you have our 2 imports up here. Now for our 2-liner, we can set a variable, because remember variables in Python are dynamic, so you can set them to print anything. You can also set them to a request as well. So you can say request. Something about Python that's different than C++ is that we can do requests. And it has that little bit of internet functionality that C++ doesn't have and C doesn't have. So we can do stuff like this. And we can do requests to a URL. And let's say, for example, we have this Fortune API right here. Like, for example, you can always request to get something from an API as well. So I can get this request right here. I get a request from it. I'd say request.get its address. It should give us. And what we should do is return a string to us. But since this is going to be returning a pretty messed up string, we're going to do eval to a normal string Python can use. We can print that to the screen. So we go here. Go c.dot, go to the previous folder. Go to 2 right here. Do Python main.py. this if you want to. Problem is, if you don't use a val, it would return a proper string. So you get something like this. You get a response. You get a response. So saying, yeah, we got the response. Basically what it's saying is like, yeah, we got the response. About it. It's like, it's the reason why we always do like a val or something like that. You just use your response instead. So, for example, look at the documentation right here. How to use an API with Python. The thing about Python is really well documented. It's probably one of the better documented questions. Yeah, that's what I was going to do. Thank you. Thank you for spoiling the answer. Sorry. I just made this morning, so thank you. Yeah, this one just gives you a response right here. We might do val. I guess it's bad callback. Okay, we'll just skip this one. We'll just talk about lists. So, in Python, you have lists, not arrays. It's not your average language. He's not like the other girls. Like she is not like the other girls. She has lists. So you have a list. You just declare an empty list by this, right here. Kind of similar to arrays in C++, where you have like the square brackets. That's how you do a list. So, very similar, except I know in C++ it's like if you do a C array, you do something like this, int a is equal to like this. Equal to like this code braces of the thing, right? You're not like the other girls. There you go. It'll be immortalized. Okay, you're gonna be immortalizing that. So, yeah, you can do various operations, kind of similar to a vector, where it's not like a C array, where it's like, yeah, you can put data inside of it, good luck getting data out of it, because all you gotta know is the index. All you gotta do is know the index. Okay, I'm sorry, I can't stop laughing after that. I think that was pretty hilarious. So, yeah, you can also do various functions. So it's like a vector. You can do functions like append, which you can append a value to it. So if you wanted to append 30 to this, you can also append anything. You can also append a string. You want to append a string to this? Here's that famous quote you guys love. Right here. Even I'm messing up. Man, even messing up and copy and pasting. You guys put me under this kind of pressure. So I can append the string. Okay, you guys are making so weird. You can also append a string to it. You can also append booleans to it. So appending is like popping to the. It's like not popping. It's like pushing to the back of a vector. So, I do true. Go. To append true to the back. I want to. Let's say you want to get rid of the true value just appended. You got pop. Just like a vector. So you could just pop to the back. You don't want to. There's a lot of other stuff you can do. Like for example, a dot. You can also sort. Look at that. You know all the sorting assignments we're going to make you do in 41? No problem for Python. You can just do it like that. So if you want to sort out this entire array and print it, you can also print. It's already operator overload for you. So you can print out the screen. This. So if I cd out of here, I cd to demo, I ls, I do python main.py. Yeah, look at that. Because it's not supported because there's a string and int here. So it has to be ints only, guys. Yeah, most things are printable in Python, believe it or not. Like I want to. There you go. Yeah, the string's printable. Not the string's printable. The entire list is printable. It's already been overloaded for you. So no point of doing like ins, right? whatever, like where you like insert or like IO stream or IS stream. There's nothing like that in Python. There is operator overloading in Python, and Aaron's gonna get into that with classes when he does his advanced workshop later on this week, next week. He's gonna go over classes and like the more abstract data types. Oh, you want to print love to the screen? Oh, I got even better. He's not like the other. That's better than love. That's better than what you want to print to the screen. You can print anything to the screen. It's just as long as it's a string. As long as it's a string, you can print it to the screen. It doesn't really matter. Like, plus you can also print dictionaries to the screen too. So when you guys go over to Dictionaries next week with Aaron, you can print dictionaries to the screen. As well as sort. So let's say I want to get rid of the string. Goodbye to the meme string. And goodbye to this string. Let's just insert a bunch of elements. So 20, 30, and this. By the way, there's not that many int limits in Python. Like, integers can get pretty big. That's the reason why they use it for data science. Yeah, it's like an array vector in C++. It's much more simpler. Just telling you the grass is green on your side. There's a very good reason why you don't use Python for everything. There's a reason why CCI 41 is not taught in Python. It's because it's too damn slow. It's too slow. It's too slow. So, for example, if we were doing that one, if you're like an input tester for one of these assignments, and you compared the times, Python is significantly slower. It's because of one reason and one reason only. C++ is a lower level language. So, the only thing you gotta know about Python, Python is right above C. Because Python goes into C when they do just-in-time compilation. Python is very close to C. It's not as close as C++ is to C, but it's very close. The thing is, you might think, oh, it's close to C, it might be fast. No, it's not fast at all. The reason why it has to literally convert down to C. That's the reason. What's the problem with higher level languages? Like how JavaScript has to go down to bytecode, then to run on your computer. That's the reason why it's so slow. It's just it's a higher level abstraction right there. You know, it's a higher level language. So like, for example, C++ is much more closer to C. And you know what C++ converts into? Assembly. You know what assembly converts into? Machine code. And that runs on your CPU. It's just a lot more close to hardware than Python is. Yeah, like for example, I can show you later on towards the end of the workshop, I'll show you one of my main projects I did, which is your 4. Which, by the way, your 4 is actually a part of my main project. The only difference is I'll let you do a couple lines I think you can do in this. So, I'll show about it later. Show a little more later. But yeah, Python is actually close to C, but it's not actually C. It's like, because once you get into like Python, you're like, oh, I hate C so much, let's learn Python. But once you get really far into it, you're basically going to say, yeah, I want Python to be more like C. It's kind of hilarious. Because it's like the language I go to when I'm frustrated with C++. Because eventually when you get good at C++, you're like, man, I wish this language was like C++. As fast it was, C++. And yeah, you can integrate Python to C++. Not C++, but yeah, you can do that, actually. Because there's a library called Cython, which lets you use C code in Python. Because the reason why I say it's really close to C, is because it compiles down to C. Because most interpreters for Python are made in C. So, that's the reason why I say that. That's the reason why Python's significantly slower. However, there's a lot of advantages of being slower. You get all this cool stuff like append. You get all this cool stuff like I'm able to print out everything in a list without doing a for loop. You get a lot more advantages to Python. It's much more beginner friendly. So you won't have to be stuck with like, oh, I can't print out an entire array because I keep seg faulting because I go too far into the list. No, you just do like a print A. There's no for loop to go through each element of the list and print it out. So like A at I, whatever. None of that messy stuff. Even though I think it's better for people to have more control of what they do. It's not as messy. Like this is basically this. That's the reason why I made you guys do the first time. It's showing you how Python is much more concentrated than other languages. Like you can do a sort within a one-line function. You can also do sort in C++ using the algorithm library, but it takes multiple parameters. It takes like a beginning and end parameter, so on and so forth. So, yeah. So you want to sort this? Do a.sort. And there you go, sorts it. And there's some read also. Yeah, sorts it. There we go. Sorts. It's completely sorted. Because of this little command right here. It's basically lists, right? Yeah, since we have a lot more time on our hands, we can probably go over class smoothly. Kind of what I'm worried about is I'm losing the CCI 1 students because it's like kind of just rushing through the language because I feel like I'm going too slow. So just tell me if I'm going too slow because I'm just kind of like the first time teaching Python to like 40 people, so I'm gonna have to fuck up somewhere. I mean screw up somewhere. Again, you're college students, so. But again, you're college students, I'm sorry. I'm gonna have to screw up somewhere. Am I going too slow on this? Just tell me. Okay, go over dictionaries. So, dictionaries. Let's chance over to dictionary. What's gonna change? Dictionaries take multiple values. I'm not going over tuples though. No. Yeah. Okay. I'm sorry. Okay. So you can also get things from dictionaries. So you can also push things into dictionaries. So if you want to. Word function. Disappointed. Okay, you know what, fine. I'm fine. Yeah, they're all very similar but different. Like, dictionaries are kind of similar to hash tables where you can have a key. So basically you have a key and a value. You guys remember how Kearney uses unordered maps where you have a key and a value? Just beep it and post. Why just true divide here? Yeah, sometimes in Python you get those weird like, oh, yeah, I accidentally typed something. So this for example of like brew, and it occasionally imports a library out of nowhere. Yeah, it's like a pair, yeah. So. Okay, I'll also go over one of my projects I did in Python, which is something I'm really proud of. Just go to File. It's actually open in our Visual Studio Code window. Let's see. There you go. So, this is something I've been doing for a while. I actually mess around with graph theory a bit. If you take 26 with Kearney, you know how much he loves graph theory. So I ended up messing around with convex halls in the last couple of days of the semester. So I turned in for my last project for CIT 95. Yeah. So yeah, when you're doing hash tables, like how it works is that you hash the value and you find what index it belongs to by modulusing it by the size. thing about dictionaries, it takes a key and it finds the value based off the key. So, yeah. By the way, if you're really interested in makefiles, it does work for turtles. Not for turtles, in Python. It does. Believe it or not, it does work. Right here. So if you want to be really cool and show off to your friends that, yeah, I know Python, but do you know Linux? You just go cd turtle convex hulls. Yeah, turtles is actually a visual library for Python. So if I showed you this real quickly, I can just do make. There you go. You want to make convex hulls? So here you go. If you know how convex hulls work, basically they're trying to make a hull around the points. So basically it goes from point to point, checking if it's inside or outside. And checks if it's too far in. If it's too far in, it goes to the next point over. So if we did this, we'll make a very nice polygon on the screen. Which, by the way, I did give you the source code for this, so if you want to look at more advanced Python, there it is. So, yeah. Plus, you can change colors too. Want to? Make it purple. Something I'm really proud of. It's just simple, like, algorithm. Like, this thing you do in 26, by the way. You're going to do convex hulls eventually. So, yeah. It's just, unlike C++, where it's like, I'm not doing any visual libraries whatsoever because I want to make a living hell for every person who uses my language. Because they don't, for some reason, C++ doesn't believe in like visual libraries for some reason. It just doesn't. They want to put Qt in the standard library thing, but I don't know. But Python actually has the standard library with visuals. So you have stuff like Dictionaries, right, where you can make your own little applications in there. Or if you're like me, you use PyQt, which basically you make your own little application using Qt. So yeah, Dictionaries. So yeah. Let me just go over this. So we have classes right here. It's kind of very similar to what you're doing in 41 right now, where you have a define function. Instead of like having a default constructor for coordinate, you have an init function, which basically initializes every single time you initialize a class. So what basically this is, it's just like a non-default constructor where I pass in itself plus the y and x value. So when I do a coordinate, like right here in the main.py, I pass in x and y as parameters. It's kind of similar when we overload the equals function in C++ for classes. Last assignment. Plus, you can also do a string too. By the way, if you do a string, it's kind of very similar to like input overloading, where you can actually overload it to be a string. You can actually use it for printing out. That's the reason why you get this printouts right here. These are little neat printouts right here. And we also have a less than operator, actually greater than. No, it's actually less than operator. We're just gonna check itself and see if it's greater than the other one. Actually, it's checking itself and so we can check if it's less than the other one. So this is a less than overload. It's very different than our other languages. We actually use something like this, where you have a define function. So instead of like, I don't know, is stream, so in stream, you know, the whole ampersand thing, you have a define. You have all these other stuff. You have format. You do init. You can also do a hash function to return the hash of itself. So if you ever wanted to hash a class, you can do that using overload. You also have a new function if it's initialized without any, parameters. There's also reduce, so you can do a lot of stuff. For example, you can do size of, which turns the size of memory of the object in bytes. You can return a string of itself right there. We did here. You can even do a call itself as a function if you want to. Plus, there's a dictionary implementation as well. A lot of stuff you can do. You can overload in C and Python. So, yeah. So let me just go close my edit. Let me just close this quickly and go back to our main file right here. So that's about it. It's basics of Python. You have your prints, your I/O, you have your if-else statements, your functions. Oh, I forgot to go over functions. I actually forgot to go over that. So yeah, Python, when you want to make a function, it's very different than our languages. So C++, you do your ints, name a function, so we call it, I don't know, get chords. I'm not naming the function that. It was an accident, please. God darn it. I'm not making that function. I'm doing the F word function. Oh god darn it. Okay, you guys are college students. You can handle that. We're gonna call this function the wholesome Christian censor. Actually print this. Actually copied and pasted it. Okay, fine. Function. I'm sorry. Function. Function. Why is my mic cut out when I did that? Okay. Okay. Function. Function. Say it with me. Function. Yeah, function. Yeah, right now it feels like a cat because I'm getting like egged on. I don't know. Censor. There you go. You can pass a string into this. You want to pass a string? Got this. Words. And oh god. So I could do like a for right here. Actually, don't do a for loop. We're actually gonna do. We're actually gonna go with the string, so we're gonna get the size of the string, and we're just replace it with x. You know what? We'll do something else. You know what? Because you guys are really messing around with your code, I'll show you how to do find is even. You're going to do is even. There you go. There you go. Because you guys are being rude. How dare you? I make you do C++ by accident. So yeah, we just do. You define the name of the function and the colon. Yeah, I know we don't do brackets, Aaron. It's just that right now it's like kind of hard to function with everyone just like dogging on me right now. So we're gonna go get the number. I am very overwhelmed right now. Right here. I haven't given you brackets again. Thank you. Yeah, it divides evenly, modulus it by 2, and modulus evenly. It turns true. Else. How do you add more blocks to an if statement? You know, you just, it's very simple. You actually just do the, because of white space defining, because of white space, you can actually just chain it like this. You can do if and if else. But yeah, there is no if else. There's actually no if else in Python. It's actually elif. Yeah. That's another thing about Python. People get. Yeah, there's no else if, it's elif. It's by right here, elif. Yeah, you want yandere dev code? You want yandere dev code? Want yandere dev code right now? So you guys are constantly roasting on me for having a nervous breakdown during this. There you go. Your yandere dev code. Your yandere dev code. Yeah, worth every single penny right here. And by the way, we don't have switch statements either. So if you want to do this efficiently, there is no switch statements in Python. There's match statements, but that's pretty new. Yeah, this is technically very cursed, because think about it, you have to start at the function, right? You're saying number divided by 2 is even, but if it's then you wouldn't even run this code, because if it's 2, it would already been returned true. This will only work if it's odd. It'll just go through each and every single elif statement. Just think about that. Yeah, like, I don't want to think about that, because like if it's odd, it's gonna go through every single elif statement and check. But as soon as it's even, which is 2, it would already return true. So all this stuff is useless and just takes up performance. Yeah, I do string comparison. So if I want to do string comparison, and I want to check if it's equal to my name, for example. Let's see, is my name we can actually do string comparisons. But the thing is, what you do here is very different from what you normally do. Since we're taking input for this function, we're taking input from my actual input function, we would actually just do uppercase. We do like we would actually put the name in uppercase. Pretty sure. Let me go check the documentation quickly.
Alright, I'm back.
Yeah, basically we can compare strings. If you really want to, let's go to the shell. I'll show you in the shell, not that. If I want to, I can just compare strings. There you go, compare strings. Something you can't do in C++, by the way. But technically speaking, if we were taking an input, you would just uppercase it. So we do Alex. Think with Alex, so for example, I typed in this, it would automatically go uppercase. So that's the reason why you would do an uppercase for that. You would, before you take it in as a parameter, you would just do like a dot upper or is uppercase. I forgot what it was in the documentation, but something like that. Yeah, you can do that. So yeah. Well, that's about it. We're done. I gotta cut it short because
Alright.
I didn't expect to get embarrassed twice in a row. So yeah.
Everybody, please get a warm clap emoji for
Yeah,
Betancourt.
thank you, Aaron, for sabotaging me. You're real helpful, man.
Alright, well, I'm going to stop the stream now. Betancourt, thank you very much for all of your hard work on this. And thanks everybody for coming out. We will see you next time.